Okay, so we are on to the Pythagorean theorem. This is our final lesson of the year. Please make sure that you have a copy of the notes in front of you. It should say Pythagorean theorem across the top. So the Pythagorean theorem is the whole reason that we spent all of yesterday talking about perfect squares and square roots. As I mentioned, I'm not going to be assessing perfect squares and square roots, but I will be assessing the Pythagorean theorem on our quiz, where you will have to use squares and square roots. So that's where you'll see this showing up into the equation today. So for Pythagorean theorem, we're going to start by labeling the parts of a right triangle. These are words and labels that we'll be using throughout this lesson, and we want to make sure we know what each one is. So starting by labeling the legs of a right triangle, the legs are the two sides that make up the 90-degree angle. So we have a leg down here at the bottom and a leg over on the side. This long diagonal line that does not make up a 90-degree angle, that is what we call a hypotenuse. I don't know if you've heard that word before. The hypotenuse is what we are going to be spending time finding the measure of today by using the Pythagorean theorem. So these legs and the hypotenuse, they also have letters that are associated with them. The two legs are going to be A and B. Our hypotenuse is always going to be C. So please make sure that you have these labels on your picture. That way, if we reference leg or hypotenuse, A, B, or C, you have that reference on the front of your notes. Remember, the quiz is open note as well, so you want to make sure these are labeled really well in case it comes in handy. Okay. We are going to have Math Antics do some explaining for you, so go ahead and pay attention. He's going to be explaining the Pythagorean theorem for you.
Okay, now that you've got all that background info covered, let's see what the Pythagorean theorem actually says. The theorem can be stated in several different ways, but the one we like best goes like this. For a right triangle with legs A and B and hypotenuse C, a squared plus b squared equals c squared. As you can see from this definition, the Pythagorean theorem doesn't apply to all triangles. It only applies to right triangles. As you know, right triangles always include one right angle that's usually marked with a square right angle symbol to help you identify it. And you need to know which angle is the right angle because it helps you identify an important side of the triangle called the hypotenuse. The hypotenuse is the longest side of a right triangle, and it's always the side that's opposite of the right angle. In other words, it's the side that doesn't touch or help form the right angle itself. In order to use the Pythagorean theorem, you need to be able to identify the hypotenuse because that's what the variable c stands for in the theorem. C is the length of the hypotenuse side. The other two sides of the triangle, the ones that do touch or form the right angle, are called its legs. Our Pythagorean theorem definition uses the variable names a and b to represent their lengths. Oh, and it doesn't matter which leg is called A and which leg is called B, as long as you keep track of which is which after you make your initial choice. Okay, now that we know the various parts of the Pythagorean theorem, let's think about what the relationship or equation a squared plus b squared equals c squared is really telling us. It's telling us that if we take the lengths of the two legs, sides A and B, and square them, which means multiplying them by themselves, a squared is a times a, and b squared is b times b, and then if we add those two squared amounts together, they will equal the amount you'd get if you square the hypotenuse side, which would be c squared or c times c. That may sound a little confusing at first, so let's take a look at a special example of a right triangle that will help the Pythagorean theorem make a little more sense. This right triangle is called a 3, 4, 5 triangle because its sides have the relative lengths of 3, 4, and 5. And by relative lengths, I mean that the units of length don't really matter. The sides could be expressed in any units, inches, meters, miles, whatever. So the triangle could be of any size as long as its lengths would have the proportions 3, 4, and 5 relative to each other. Starting with the side that's 3 units long, which we'll call side A, what do we get if we square that side? Well, in arithmetic, squaring 3 means multiplying 3 times 3, which equals 9. And the geometric equivalent of squaring something actually results in a square shape. As you can see, this square contains 9 unit squares. So this red area represents the value a squared in the Pythagorean theorem. Next, let's look at the side that's 4 units long, which we'll call side B. Squaring 4 means multiplying 4 times 4, which is 16. Again, the geometric equivalent of that is a literal square that is 4 units on each side and covers a total area of 16 units. So this blue area represents b squared in the Pythagorean theorem. And finally, let's deal with the hypotenuse, or side C, which is the longest side. It's 5 units long. Squaring 5 means multiplying 5 times 5, which is 25. And the geometric equivalent is a 5 by 5 square that has an area of 25 units. So this green area represents c squared in the Pythagorean theorem. Now that you can see how the arithmetic parts of the Pythagorean theorem are related to the geometric parts of this right triangle, let's check to see if the Pythagorean theorem is really true, at least in this special case. On the arithmetic side, if you add up the amounts a squared and b squared, they really do equal c squared, because 9 plus 16 equals 25. And with a little rearranging of our unit squares, you can see that the area of the squares formed by the 2 legs really does equal the area of the square formed by the hypotenuse. Wow, those ancient Greek dudes really were smart. Okay, but I know what some of you are thinking. That's cool and all, but why should I even care about the Pythagorean theorem? What's it good for? Well, as always, that's a good question. And the answer is, like many things in math, the Pythagorean theorem is a useful tool that can help you use what you do know to figure out what you don't know. Specifically, if you have a right triangle, but you only know how long 2 of its sides are, the Pythagorean theorem tells you how to figure out the length of the third unknown side. For example, imagine that you have a right triangle that's 2 centimeters long on this side and 3 centimeters long on this side, but we don't know how long the hypotenuse is. No problemo. The Pythagorean theorem tells us the relationship between all 3 sides of any right triangle, so we can figure it out. We know that a squared plus b squared equals c squared, so let's plug in what we do know into that equation and then solve it for what we don't know. Again, it doesn't matter which of the 2 legs is called a or b, so let's just label them like this and then substitute 2 for a and 3 for b in the Pythagorean theorem equation. That gives us an algebraic equation that has just one unknown, c. If we solve this equation for c, in other words, if we rearrange the equation so that c is all by itself on one side of the equal sign, then we'll know exactly what c is. We'll know the length of that side of the triangle. First, we need to simplify the left side of the equation since it contains the known numbers. And according to the order of operations, we need to simplify the exponents first. 2 squared is 4, and 3 squared is 9. Then, we add those results, 4 plus 9 equals 13. And we have the equation 13 equals c squared, which is the same as c squared equals 13. Then, to get c all by itself, we need to do the inverse of what's being done to it. Since it's being squared, the inverse operation is the square root. So we need to take the square root of both sides. Taking the square root of c squared just gives us c, which is what we want on this side of the equation. But it gives us a little problem on the other side, because it's not easy to figure out what the square root of 13 is. It's not a perfect square, so it's going to be a decimal and probably an irrational number. But that's okay, because it's fine to just leave our answer as the square root of 13. Sure, you could use a calculator to get the decimal value if you really need one, but in math it's very common to just leave square roots alone unless they're easy to simplify. So the sides of this right triangle are 2 centimeters, 3 centimeters, and the square root of 13 centimeters. Let's try another example. For this right triangle,
Okay. So on the front of your notes, you have an example of what he was just talking about. And we have our formula, a squared plus b squared equals c squared. You've probably heard this formula before, but just never knew what it was used for. This is our formula for the Pythagorean theorem. Go ahead to the inside of your notes and we'll actually start trying some of the Pythagorean theorem for these examples. Our first example, we have a triangle with 15 feet, 8 feet, and then an unknown length for C. We are going to be using our calculators. If they're not on the desks, please go ahead and grab one. I have a note in my subnotes that you are to have it, so no worries there. So make sure you get yourself a calculator. You're going to want it. So some calculators do not have the x squared key that we've been using. So if that were to ever happen, you would just multiply to get that number squared if that ever comes up. But for today, you have access to this button, so we will be using it. So our formula for the Pythagorean theorem, we have a squared plus b squared equals c squared. Now we need to plug in the measures. If we remember the label on the triangle on the front, our bottom leg here, this is A. Over here on the side, this is B. This creates our 90-degree angle. And no, it doesn't matter. So if you label this as B or this is A, it does not matter. As long as you identify that the two sides that create the 90-degree angle, those are the legs. Those are A and B. That's all that matters. We can plug them into our formula. So now we have 15 squared, because that's one of our legs, plus 8 squared, also one of our legs, is equal to c squared. We don't know c. This is where we're going to need our calculators. So in our calculator, we are going to type 15, and then we're going to hit that x squared button to get that 15 squared. And that's going to give us 225. And 8 squared gives us 64. And hopefully you knew this one, because this is one of the ones that we've been talking about a lot yesterday. It's more familiar. But we now know that 225 plus 64 is equal to c squared. So let's go ahead and get this sum of 225 plus 64. We have 289. 289 is equal to c squared, but we have a slight problem here. Oops. We know what c squared is, but we need c. So we have to think, how would we do that? Well, if you were paying attention to the Math Antics video, if you didn't completely check out, he did explain this. This is where our square root is going to happen. We have to do the inverse. I see c squared. So this means I need to take the square root. So if I take the square root of 289, I will find out what c is. So again, on your calculator, hit that second button that we talked about, and then hit the x squared button, and it will give you that square root. Then type in 289, and then use the parenthesis that's right above your 9 to close the parenthesis and hit equals. We find that c is equal to 17. The square root of 289 is 17. So by using the Pythagorean theorem, we found the length of the hypotenuse. We found what c equals, 17. Try these two. Give yourself the formula, a squared plus b squared equals c squared. Plug in your values and see if you can do this. Pause the video, give it a shot, press play when you're ready to check. Okay, let's work on this first one. A squared plus b squared equals c squared. A and b, these are our two side lengths that make that 90-degree angle. So we have 24 squared, I got that right here, plus 10 squared over here on the side is equal to c squared. So from here, we need to find the value of 24 squared and 10 squared. So in our calculators, we can type 24 and we can hit that x squared button, and that will tell us what 24 equals, or sorry, 24 squared. 24 squared gives us 576, and 10 squared gives us 100. So 576 plus 100 is equal to c squared. We need to get this sum. 576 plus 100 gives us 676, and that's equal to c squared. So once again, we found c squared, but I want to know what c is. In order to undo a squared number, we have to take the square root. So if I take the square root of 676, so again, on your calculator, if you hit that second button and the x squared button, you type in 676, close that parenthesis, equal, we find out that C is equal to 26. So our hypotenuse is 26 units. Let's try this one, and it may have freaked you out because it has decimals, but it's still going to be the exact same process. Just because they're decimals doesn't mean you can't square them, and just because they're decimals doesn't mean you can't take the square root. So everything will work out just fine. A squared plus B squared, we need our legs of our triangle. So again, the legs create the 90-degree angle on the triangle. So I use 9.6 for A and 7.2 for B. So 9.6 squared plus 7.2 squared. We need to find out what these equal, so I'm just going to type 9.6 and hit that x squared button on my calculator. And the same thing for 7.2. I get 92.16 and 51.84. I need to get this sum, so I'm going to add these two together. And we get 144. That worked out nice and clean. So 144 is equal to C squared. So again, we have one last step. I need to undo this squared. I need to get the square root. So I'm going to do the square root of 144, and we find that C is equal to 12. So our hypotenuse here, the length of our hypotenuse is 12 feet. Let's try a couple more. We have two that are on images. They're not just a basic triangle. So we have what looks to be a computer monitor, maybe a TV screen. I don't know if you know this, but whenever you see TVs for sale and it tells you how big it is, the measurement of a TV or a computer monitor, those are from corner to corner. So when they tell you that it's like a 40-inch TV, they're telling you the hypotenuse. For some reason, that is how we measure screens. So we are going to find out the size of this computer monitor by finding the hypotenuse. The first thing we need to do is we need to write down our formula. So we need to write a squared plus b squared equals c squared, so that can help us stay organized. Then we can plug in our two measures. Our a squared, we're going to do 32 squared. And then our b squared, we have 24 squared. And that is equal to c squared. So now in my calculator, I'm going to do 32 squared. So I'm going to type 32 and I'm going to hit that x squared button. Same thing for 24. I'm going to type 24 and I'm going to hit that x squared button. And we find that we get 1024 plus 576 is equal to c squared. We have to get this sum. We're going to add them together. And we get 1,600 is equal to c squared. So again, we have to figure out what the square root is because we don't want c squared, we just want c. So we take the square root of 1,600 and we find that this is a 40-inch monitor because we use the hypotenuse to determine the size of a screen. So this is a 40-inch monitor. And since it's a measure of distance here, it's not an area. So notice I'm not doing inches squared or inches cubed. It's just 40 inches. That is our measure. Try this house one on your own. Find the hypotenuse. So you're going to find how long this ladder is using our formula a squared plus b squared equals c squared. Pause the video, give it a shot, press play to check your answer. Okay, so let's go ahead and see how you did. So we know we're going to be using a squared plus b squared equals c squared. Our a squared and our b squared are going to be these two measures here because these are creating our 90-degree angle. So we have 60 squared plus 40 squared equals c squared. So we have to figure out what 60 squared and 40 squared are. So in our calculator, again, we would type 60 and hit that x squared button, and 40, hit that x squared button. We get 3,600 plus 1,600 is equal to c squared. 3,600 plus 1,600 gives us 5,200. So 5,200 is equal to c squared, but I just want to know what c is. I want to know what the length of this ladder is. So I have to take the square root of 5,200, and it does give us a really long decimal in our calculator. And when that happens, just like we did yesterday when we were doing the square root, we would round to the nearest hundredths place. So we end up finding out that our ladder is roughly 72.11 feet. Okay, so that is the Pythagorean theorem. Keep these notes safe because, again, it's an open note quiz. You do not want to lose these because you're going to want to have that guide. You are going to get the worksheet now. Get started on the worksheet. Show your work. I know you're going to be doing a lot in the calculator, but at least write the formula that you're going to be typing in. So, for example, I don't need you to write every single step for me, but at the very least, write this part, this middle part. Show me what you're squaring. That way, if you have any mistakes and you're not sure why your answer is wrong, I can see what you did when you originally set it up and maybe see if there was a mistake there. So once you do all of that and you get it completed, if you get it completed, make sure it goes into the bin. And then from there, go work on any of the missing assignments that you have, because we need to make sure we get all of those missing assignments turned in. If you have nothing missing, work on your sneaker project. If you have your sneaker project finished, then you can work on whatever it is that you'd like to work on.